again, and welcome to one of I think it's our third last video of this series on algebra and linear equations. We are going to be picking up where we left off last video when we were solving some more basic equations. Today we're going to be testing your knowledge on solving equations by throwing in some harder ones in there. So we're going to be working out of exercise 2G, I think it is, and let's show you what questions we're going to be up against. Now remember, before we get too far in, you need to remember, like in the last video, to keep your equations balanced. So when you are starting to move stuff around on both sides of the equal sign, you need to remember to what you do on the left, you must also do on the right hand side as well. Alright, let's get straight into these examples. Now in this particular question here, example 1a, you'll notice that straight off, we have brackets, not on the left-hand side, but also on the right-hand side as well. Now, with these types of questions, it's important that we expand the brackets. Now, the problem with the left-hand side, because we have two, sometimes it can get a bit confusing because we have this minus sign in the middle. So we're subtracting whatever's going to be expanded on this side by whatever's going to be expanded on this side of the minus sign. So what I like to do to help me separate the two is I like to keep the brackets in play and put it around the working that I get from expanding the brackets out. So the first one that we have 6 times 2x, which is 12x. Then we have 6 times minus 3, which is minus 18. And then I close the bracket so that I know that this first group is what I expanded down here. Now I'm going to subtract away from that the expansion of the second one. So that's 2 times 6, which is 18, and 2 times minus 3x, which is, that's right, minus 6x. Now there is another way to approach this question. Instead of adding more brackets, if you find that confusing, what you could do instead is lay everything out before you start combining your like terms. So you got 6 times 2x, which is 12x, 6 times minus 3, which is minus 18. Now to help you not get confused with this minus sign, incorporate it in to the 2 here when you're expanding. So minus 2 times 6 is minus 12, and minus 2 times minus 3x is plus 6x. Now we've got some different signs in front of our terms than what we have over here, but it will sort itself out. So depending on which way you like to expand will determine how you approach this question. Now over on the right hand side, the expansion is 14x minus 7. Now if you're doing it this fashion over here, so this is just 14x minus 7. So this is just going to be a simple case of combining your like terms. So 12x plus 6x is 18x. Minus 18, take away another 12 is minus 30. And that equals 14x take 7. Whereas over here, it's a little bit trickier. We've got 12x take away minus 6x, so minus turns it into a plus. So 12 plus 6 is 18x. Minus 18, take away, oh, we've made a mistake. This is supposed to be, my apologies, this should be, instead of 18, this should just be 12. Minus 18, take away 12, which is minus 30. And that equals 14x take away 7. So we've come to the same answer. It's just two different ways of setting it out, and it's completely up to you which way you would like to do to answer the question. Alright, let's finish solving it on this side. So this is now an equation with a pronumeral on both sides of the equal sign, similar to what we did in the last class. So 14, to get rid of the 14 over this side, we are going to subtract 14x from this side and subtract 14x from this side. So that gives us 18 minus 14, so 4x minus 30 equals minus 7. Then we're going to plus 30 to this side, plus 30 to this side. So that 4x equals 23. Then we're going to divide by 4 on this side, divide by 4 on this side, so that x equals, well, we're going to leave it as a fraction, 23 over 4. Okay, let's have a look at now example 1b. Now this is going to get back to our work with fractions that we did a couple of exercises ago. If we want to combine our pronumerals that we have here, we are going to need to combine our fractions, which from our adding and subtracting fraction exercise that we did on both, I think it was Monday, or was it on Thursday and Friday last week, we're going to make a common denominator. Now, for those of you, hopefully you've got enough practice, our new common denominator using 4 and 5 is going to be a fraction with a denominator of 20. Now, our numerators are going to change as well. This one was multiplied by 5, and this one was multiplied by 4. So that now on the top here we've got 5a, and this one we've got 4a, and that equals 3/4. Now we can combine our fractions, which says 5 minus 4 leaves us with a over 20 equals, oops, let's get rid of that, 3 over 4. Now this is just a one-step equation now, and to get rid of the 20 we're just going to multiply both sides of our equation by 20, so that a equals 60 over 4, which equals what? 15. Good job. Alright, now that's probably one of the easier fraction ones. We're going to come across a couple now which are in fact a little bit harder. Take this question for example. First of all, the pronumerals are no longer on the top, but now they are located on the bottom. Second of all, they're not on the same side of the equal sign. They are now separated. One is on the left and one is on the right. So to begin this question, in my opinion, the best way to answer it is to move the pronumerals to the same side and move the straight numerals, in this case the 1/6, to the other side, so that we can have a question that's similar to B, where the A's are on one side and the other fraction is on the other side. So to do that, what we're going to do is simultaneously add 1/6 to both sides, so we move it from the left to the right, but what we're also going to do is subtract minus 2 over e from one side and minus it from the other side. So that moves the 2 over e from the right to the left, and adding 1/6 is going to move that from the right to the left, and we're going to do that in one step. So our new question is going to be 4 over e take away 2 over e equals 1 over 6. Now that we have the pronumerals on one side, we can work it out similar to what we did in part B to get our common denominators and then move it around so that we find out what e is equal to. Luckily for us, the denominator is already the same, e and e. So it's just a simple case of subtracting 4 and 2. So 4 minus 2 gives us a new fraction of 2 over e. And that equals 1 over 6. Now when we have one fraction on both the left-hand side and the right-hand side of an equal sign, this is where we use a method called cross multiplication. Now this method is only to be used when there is one fraction separated by another by this equal sign in the middle. For any other method, going back to the last few exercises, whether it's multiplication and addition or division and subtraction, you do not use cross multiplication with those methods. It is only in these examples. So from here, we can cross multiply to find out the value of e. And to do that, we multiply the bottom of this fraction by the top over here. And we do the same with the left-hand side and the numerator on the right-hand side. It creates a cross, and that's why it's given the name cross multiplication, because you multiply by doing this method here. So that gives us 6 times 2 is 12, and that equals e times 1, which is e. And luckily, that has given us our final answer, which is e is equal to 12. Okay, moving on to the next question. In this example here, you'll notice that it is similar again to both question C and B. We have two fractions, and each of those fractions has a pronumeral in it. In this example, it's the letter A. The difference between B and C and this example here is that on the right-hand side, there is nothing. It's just 0. On the left-hand side, we have two fractions with pronumerals, so unlike C, we don't have to move them around because luckily they're on the same side. But in this question, there is nothing over on the right-hand side. Now, this is good for us because what that means we can do is if we move our second fraction over here to the right-hand side, it creates a scenario very similar to what we had in this step up here of this question. We will have one fraction on the left-hand side and one fraction on the right, only separated by an equal sign. Now, why that's so good is because then we can use the cross multiplication method we used in this example to solve it. Rather than going through the hassle of doing common denominator, adding them together, and then rearranging it to find out what the answer is, it's an easier method of simply cross multiplying. Now, if this isn't something that you would prefer to do, you can still get the correct answer by doing the common denominator method that we looked at for part B, or example 1b. However, I will be showing you the easier way, which is the cross multiplication. So the first step is to subtract this fraction because it's being added. Remember, we do the opposite. We subtract it from this side over to the other side. Therefore, our question is now going to look like 2, and in brackets, a plus 1 over 7, and that's going to equal, because we've subtracted it, minus 3 bracket 2a minus 5 over 8. Now we can cross multiply like we did in this step up here. So we're going to multiply the 8 by the numerator up here, and we're going to multiply the 7 by the numerator up here. So our question will now become, well, 8 times 2 is 16 bracket a plus 1, and that's going to equal 7 times minus 3, so minus 21 bracket 2a minus 5. See, by doing cross multiplication, we've now got a question which looks much easier and doable than dealing with such a large fraction back at the beginning. Okay, our next step, we're going to expand our brackets. So this will be 16a plus 16 equals minus 42 2a plus 105. Alright, now we've got a two-step equation which we can rearrange. So let's add 42a to this side, add 42a to this side. So that will give us plus 58a plus 16 equals 105. Then we subtract 16 from both sides, so that we have 58a equals 105 minus 16 is 89. Then we're going to divide both sides by 58 to give us a equals 89 over 58. Now, while I was showing the working out for that, I rushed through these steps here, the plus 42 minus 16, because by now you should know how to balance your equations by doing both sides, doing the same thing to both sides, sorry, and what order to do things. If you're still not sure, either re-look at the video that did solving basic of equations, or come into class and get a catch-up on how to do, or what order to do your basic equations in. Okay, last example, E. So far you've noticed that the rest of these examples we've done have involved fractions, so it's combining the skills of the exercise we did on solving algebraic equations with the skills that you learned in the previous exercise of solving basic equations. The difference between the others and this particular example is the fact that now we not only have a common denominator on only two of these fractions here, but we've got a pronumeral on all three fractions. So this is going to require a little bit of working out, but we'll be able to get through it in the end. The first thing, like I said earlier, was the fact that two of these fractions already have a common denominator, which is y plus 1. It's important that before you try and solve some of these equations, especially the more tougher ones, is that you take a second to try and look at what you have in front of you. And the first thing that should jump out of you is that these two denominators are exactly the same. That means we will be able to combine both of them easily before we start messing around with the y minus 4. If you don't recognize that and you try and start merging these two fractions immediately, you'll realize that when you come to this one, while you still may get the correct answer, it's going to make your life a lot more difficult than if you'd combine them at the beginning. So what we're going to do is we're going to subtract 3 over y plus 1 from this side and subtract 3 over y plus 1 from this side to simplify our equation. So by subtracting it, we remove it from the left-hand side, and we're left with 5 over y minus 4. And on the right-hand side, because we have a common denominator, all we have to do is subtract the numerators from each other. So 5 take away 3 is 2 over y plus 1. So by doing that move, we have simplified it into an equation that replicates what we did in example 1D. We have a question with two fractions that are separated by an equal sign, and once again we can cross multiply to get our final answer. So cross multiplying here and across here like so will give us a question of 5 times y plus 1, and that will equal 2 bracket y minus 4. Now we'll expand the brackets. 5y plus 5 equals 2y minus 8. Now, like all the questions, we've ended up with an equation with pronumerals on both sides. So we're going to subtract 2y from this side, subtract 2y from this side. So that will give us 3y plus 5, and that equals minus 8. Then we'll take 5 from here, take 5 from here. 3y equals minus 13. Divide by 3, divide by 3. Y equals minus 13 over 3. So what looks like a really complicated question at the beginning turns out to be quite easy just by simply moving one fraction from one side to another. So if I can help you out for the upcoming test, the one thing that I would say is that sometimes a complicated question is only there to in fact scare you, and if you can realize that it's just a matter of doing one simple thing, that will change the question completely and end up making it a lot more solvable than you originally thought. Anyway, that brings us to the end of our third last lesson on this chapter. I hope you've enjoyed it, and I look forward to seeing you again soon. Again, I'm Mr. Rappell, and I'll see you guys in class tomorrow. Bye.